Hello, good morning, good afternoon, good evening. Welcome on the next workshop, live Tekla workshop on Learn Grasshopper platform. As always, we are starting at 2 p.m. Central European time. I'm seeing that people are gathering. Hello, Andre. Today we have a guest. Can you hear me?
Yeah, I can hear you. Hi.
Yes, I can hear you as well. Hello, Andre. Where are you right now? Are you in Czech Republic?
Yeah, I'm in Czech Republic in Prague.
Perfect. So today we have Andre Janota, a bridge designer, computational engineer. So just let us know if you can hear us well. As always, we are starting soon in 5 minutes. So we are going to share it. So how long have you been designing bridges, Andre? Always? Have you always designed bridges, or you switched from buildings, or always bridges?
Yeah, I have always designed bridges, except the first year after my graduation, when I was in a small apartment which designed industry structures, mostly steel, but it was quite small structures. But then I switched to bridges, and now I'm in a tunnel department.
So you are working in AFRI?
Yeah.
Correct. Double check digital engineering. Hi, I can hear you. Good to see you here. Let me see. We'll start in 3 minutes. I'm just checking everything is all right. So in this one, we are going to have a split a little bit presentation. So I will take some of the parts. Andre will come back in about 20-25 minutes. So he will share his work, amazing work about the reinforcement, creating reinforcement in Tekla, and then a little bit about how we can also work with the terrain. Have you always worked with Tekla, or have you been working with different softwares?
Honestly, we mostly work with Grasshopper. We try to do all the stuff or most of the stuff in Grasshopper, and Tekla is mostly used for enforcement. We are quite an exception from, for example, Nordic countries. They do all the drawings in Tekla, but we are used to AutoCAD, so we go with Grasshopper in most of the cases.
So this is a really interesting case study that you are not using Tekla for drawings. When I first saw your project, that was amazing. Today we are not going to show that, but maybe next time on the next workshop, people will be interested to see how you are working. We have David. Hi, David. Nice to see you here. I see that Grasshopper Tekla community is growing. If you have just a question to all the audience, if you have ever been on my workshop, just write on the chat. We had already 6 workshops. Andre, have you been on any of the workshops?
Yeah, I passively listen to most of your webinars.
That's which one you liked most?
Well,
Or maybe which topic was interesting about reinforcement, about component, about drawings? Have you seen that about drawings?
no. I the reinforcement one.
Okay. We have Alexander. Hello, Alexander. Nice to see you. You already seen some examples that we are going to present today, but I think you are going to surprise you. This one, Tobias, as always, good to have you here. Let me see. I will check. Everything is working. So we will start in 2 minutes. People are gathering. I see that people are also on LinkedIn, and we have more here. Okay, so we have some people that are first time on our workshop, so that's good. So hi, Mohammed, nice to meet you. So today you will also get all the links to the previous workshop. They are available on the YouTube channel, so you can still catch up with everything. So this is one of the last from this series, unfortunately, but I will share the good news at the end that it's not the end of the series. Okay, so we have more people. Christopher, hi team. Is someone from your team, Andre, joining this workshop?
Not yet.
We'll see. We'll see. Maybe some people will come. Okay, so yeah, it's already 2 p.m. Central European time. We can just start it. So Andre, I will come back to you in 20 minutes. So I will present some first topics, and then you can join.
Okay. See you.
Perfect. See you. See you then. So yeah, so now let's start it. So we are live on Facebook, on LinkedIn, and YouTube. As always, you can give a like, or you can write a comment, or subscribe, Learn Grasshopper. I will really appreciate that. So without further ado, we have lots of people from Finland. Hello, Yuka, Giuseppe from Italy. Nice to see all of you. It will be 2 hours, but I think we'll close it a little bit earlier. It depends about the questions. Recordings will be available after registration, so you can go to learngrasshopper.com/workshop Tekla Bridges. If you haven't received an email with the link to YouTube, so you will get recordings after the registration. We will also going to share presentation with all the links that we are going to have here, but only for registered users, and the Grasshopper script that you will choose at the end. And as always, we are here for you. Today I have Andre as my guest. He will join later. So we will going to present really interesting case studies. We have Willie from France. We have from Buckingham, from people from Bangkok. Nice to see all of you. Okay, so we started this series in January. So it was the 5 steps to learn Grasshopper. Next, it was about reinforcement. In February, in March, we talked with Tautovides about using components, how we can create our own components. The fourth one was really interesting for me because it's something new, how we can automate drawings in Tekla. Today, I will show some examples for bridges as well. And last week, we have the session 8th of May. We have a session how we can apply Tekla and Grasshopper for building projects. And now, finally, we are on the end of this workshop series that we are going to talk about bridges. So for those who are seeing me first time, I saw some comments that people are seeing me first time. My name is Chris. I'm a founder of learngrasshopper.com. I've been working with Tekla for more than 10 years. I'm a bridge designer. After 10 years working as a consultant and bridge designer, I decided to create my own company and to spread the knowledge about using parametric design, about programming. So my aim is to transform engineering work into fun with use of programming. So I have my YouTube channel, I have my newsletter, but I'm also really active on the academia. I'm an academic lecturer on the NTNU, Norwegian University, where we already introduced Grasshopper for the last semester of students. Okay, so that was a smart introduction. Andre will join us a little bit later. So we can start, in my opinion. I think that we are ready. We have all people, all the community, Carlos, Jan. That's good to see all of you here. So let's start. So we are going to go to the first point on our agenda, Grasshopper workshop. Then I will show a few words about the first edition of the Tekla super user community that we will close on Thursday. And at the end, it will be Q&A session. So all the questions that you can ask about the community trainings and whatever, ask me everything. I try to answer every single your question. So let's start with our picture this picture you're going to see for the whole today workshop. So this is 7 different areas of practical application of Grasshopper in Tekla for bridges. And of course, we can use Grasshopper for 3D modeling. So we will see lots of examples with that. But I will also show you that we can look on the Grasshopper a little bit from different perspective, a little bit as our partner to make a quality assurance, to create visualization on our models. So let's start with the first bridge deck. I've been designing bridges in Tekla for 10 years. And before Grasshopper, before Bridge Creator, we have a beam extruder. And actually, it was pain in the ass making in the beam extruder. For those who are not familiar, you are making like lots of long beams, like sliced into pieces, and in this way we could create a bridge geometry. Nowadays, we have 2 different ways in Tekla to create bridges. The one way is to use the Bridge Creator. it's an additional plugin. I think in 2024 it's already integrated, and we have Grasshopper. So for those who are watching that workshop, please share if you are already using one of these, if you are using Bridge Creator, or maybe if you are using Grasshopper. Just write me on the chat, so I will also know how many of you are familiar with Bridge Creator and Grasshopper. I'm a fan of Grasshopper. I've been using some of the Bridge Creator, and it's a good tool. But I will also show you what are advantages and disadvantages of using Bridge Creator and also Grasshopper. So just let me know in the comments what you are using. Jordi, Grasshopper here, a big fan. I still never for both plugins, so good that you will see the advantages and disadvantages of two of them. So let's start with the Bridge Creator. So Bridge Creator is a plugin that you can really easy start with. So it's everything is user-defined, user interface is everything inside Tekla. It's integrated as an external plugin. So it's really user-friendly. So you don't have to be you don't need to know Grasshopper and visual programming. You can just start and use it as another tool. So it's a really extra point for that. So you don't have to pay. I think it's still a free version. So it's also big advantages. Like disadvantages of Bridge Creator and why I'm not a big fan of it is that sooner or later you will find the limitations. Maybe it's okay for some modeling of the bridge, maybe some of the retaining walls, but sooner or later you will not automate things as you could that. So here the tool of the Bridge Creator is just for 3D modeling. I will take a look if we have Einar, for example. Hello, Einar, familiar with Bridge Creator, but looking into transition more into Grasshopper. Yes, and this is, I understand you why, Einar, because if you would like to just go with bridge modeling, that's okay. But if you would like to go beyond that, make a reinforcement, make a quality assurance tool, so maybe you will see the difference. Double check digital engineering. We have made a couple of different types of network Rails bridges through Grasshopper. So it's again more people with the Bridge Creator. So let's go to another slide that will show advantages of Grasshopper. So it's more than 3D modeling too. So we can work more with the reinforcement. We can create another types of elements, not just linear elements, which is Grasshopper is good and Bridge Creator, but we can also create different types. We can also connect to different finite element software. And this is also a huge benefit that we can send some geometry of prestressed cables from one software to another. Practically, there is no limitations, of course. We have some limit of components, but the advantage is that in Grasshopper, we can implement C# and Python coding, so we can go beyond that. In Bridge Creator, we have some limits what we can achieve. And if we would like to add some functionality, we have to write to developers, and then maybe after a couple of months, years, we'll get the updates. In Grasshopper, we can create on, so we don't have to wait for new updates. What are the disadvantages of Grasshopper? We have to also say a little bit about that. First of all, you have to pay for a license. It's a Rhino license you have to buy, but the advantage is that it's a lifetime access. So if you buy a Rhino 8 license, the costs are, I think, 10 times less than the license for full Tekla version. And in addition, you get the lifetime access for Rhino. And the second, it requires basic knowledge of parametric design. So this is comparing to Bridge Creator, that you don't have to know any programming language like Python or C#. Here, you still don't have to know text-based programming, but you have to know visual programming. So I will show you right now one of the examples, how we can create quite easy bridge deck geometry from our 3D lines. So here you can see 3D lines in 3D DVG. We have top lines for, you can see the 3 red dots. And just by copying and offsetting the dots, you can see that we can create the whole geometry around that. So we can create all the lines, 3D lines, that will continue with the bridge deck. So here is the workflow that we have to make some manipulations, and we have to connect from one point, from one line to another to create surface, and then we can create a mesh. So in this way, we are connecting all the lines that going. You can see also that this bridge is extending at the edges. So that's why we are using Grasshopper for that. So after that, we can just create a mesh, and voila, we have all the geometry. So you can see the workflow can be really, really easy. Okay, so that was really quick about first application. It's for 3D modeling, but you will see today that you can model not just only plate bridges like here, but also different types of cable, stay cable bridges or free cantilever bridges. Let's go to another topic about the 2D drawings. From my last workshop, like most of people were interested in the 2D drawing automation. And here I will present a really cool example of the free cantilever part bridge that we have 20 of segments. And the aim, the task here was to create for every single segment different cross-section. You can imagine maybe your project that you have to take some cross-section to make a quality assurance. I've been working 6 years already in Norway for model-based project that we don't have to create drawings. But to be honest, I'm really fan of 2D drawings because it's a type of quality assurance that you are modeling in 3D, but on the 2D, you are going to check if everything is correct. So I'm fan of 3D delivery, but I'm also really fan of making quality assurance. And making a task in the automatic way, in the Grasshopper as this, can really simplify this process. So let's go through this example that we have on the bottom. You can see Tekla. Sorry, I will just play the video. So here we can see that we have these elements. So let's say that is 20 elements. We are just selecting them, and then we will get automatically plan view on our drawing section. And you can say in this point, okay, Chris, we can do the same, just a simply GI drawing, and we can also take a longitudinal section. So these two things are really simple to do in just pure Tekla. But the whole magic starts right now, that we are going to our script. We are going to select all our profiles or our segments that we have here. And you can see, if you pay attention, you will get cross-section for every single segment. So you will see from left to right, we are getting all the cross-sections, and they will be also put below the section. So you will get all the sections that we specify, and then we are playing the script for dimensioning. And you will get all the dimensions. So for every single part that you are defining, if you are changing, so if you can define that for every single segment or maybe in every single meter. So in this way, we've been working, for example, to make quality assurance for prestressing cables, that we have defined some section that we would like to take, and without manual drawing production, we have created a bunch of drawings that can be done in Tekla or exported also to AutoCAD. Just let me know, how do you like this method of working? Just write if you see application. I know that bridges are not that standardized as, for example, sandwich walls in buildings, but maybe you can already see some possibilities of drawing automation. So just let me know in the comment, and I will continue with that topic. So these drawings can be also displayed on 3D. We are in the building information modeling world. Everybody is talking about 3D delivery, model-based without drawings. But as I said before, I'm really still fan of drawings. I like that to see on my 3D structure some dimensions, some numbers. Like as you can see in this one, we have the kilometers above the bridge with some small tags. And in this tag, contractor at the site can easily take a section. So for example, take a plane to check in what coordinate, what are the distances, and so on. Before, this information was in the 2D drawing. where is the kilometer distance from the start and where the section is ending. Here we can define in this way. Moreover, we can also, as I showed you before with the section and dimensioning, we can take this also and project that for 2D on the 3D. So we can see right here. So we will get some information about thickness, about the width. And this is really great product that we're delivering on site. We can say to contractor, okay, you can measure by your side in, let's say, in some IFC viewer, that you can measure what is the width, what's the height of our bridge deck. But I really like the method that's showing the data, that to be sure that we are designing everything correct. So I would like to create some 3D models that are combined, like a mix, like a hybrid solution between 2D drawings and 3D, because in my opinion, we will going to deliver a best quality model. Mario, some question, is that Trimble? Yeah, it's Trimble Connect software. Yes, Tobe, this is Trimble Connect. Rhino is best money spent ever, cheaper than 1 year of AutoCAD. That's true, and still, you are paying for lifetime access, so the costs are not that big. Let me see, but it's written in Tekla model, correct? This model is exported with the Tekla. And continue with that, I said about some examples about creating quality assurance of pre-stressing cables. So in this bridge, still we have these kilometers along the way with some tags that we have cross-section. But in this case, we would like to also create some dimensions for our pre-stressing cables. So you can see we have thousands of dimensions just to check it if everything is all right. It was not just to be correct. It's not that we have delivered this model to contractor. That contractor has to go to model and check the dimensions for every single point of the cable. We have delivered to a contractor all the 3D geometry of every single cable with the points, with the coordinates, but also we have delivered that in the Excel spreadsheet. So all data was in the digital format. But the reason why we made this dimension in 2D was to make a quality assurance, that we could sit together with someone who was calculating this bridge and check for some cross-section if everything is all right. And I think it's a better way to just clicking on the model and measuring one by one. This kind of simplification really makes our model a better product. So let me know, what do you think about this combination of two words, about 2D drawings and about 3D modeling? Maybe have some of you tried it already? Let me see, I will check the some questions just to write the difference. And soon, let me see, we will, after this 2 points, after bridge deck and after 2D drawing automation, we will go to Andre, that we will present a little bit about the reinforcement. So we have some comments. The time I spent preparing the drawings for the client of the Ranselva bridge. Correct. So you can prepare some cross sections that are defining along the bridge without doing that manually, and I think it's a really game changing. Okay, we have Andre together. Hello, Andre. Good to see you. Yes, I can see you, hear you. So let's go to the next point from this presentation. So we are going to talk about the reinforcement. So I will share your screen. So if you could share, I will just short introduction for those who haven't seen Andre in the start of this workshop. So Andre Janota is a bridge engineer working in AFRY. He's been working a lot with Grasshopper and uses that for Tekla. So today he will going to share his work about reinforcement, how we can automate reinforcement, and how to also work with the terrain. So I will share your screen. The floor is yours. So what are you going to present to us today?
Hi, thank you for the invitation. Today I would like to present our one of our workflows, which deals with the reinforcement of different, say, part of structures. All the showcases will be about bridges, but what I like about this workflow is that it's quite universal because it's not field specific. You can use it in a tunnel department or in a bridge department, building department, because it's general workflow. And you can use it on multiple different shapes of your structure. And I think it's one of the most successful workflows we developed here in A3 because even the summer workers were able to use it, and it was a starting point where they started to learn with Grasshopper and Tekla, and even more the designers who don't work with the Grasshopper every day were able to learn that workflow. First, I would like to say a little bit about the history, why we or how we found the workflow. It started a few years ago when my colleague started to work on a project. His goal was to design 3 very similar bridges, frame bridges, and he was able to produce the one Grasshopper script which created the geometry of the bridge for all of 3 of them, and he included also the reinforcement of the bridge, and every part of was parametrical. Then he changed the inputs and has 3 let's say bridges. But
so you're saying that even summer students that came to AFRI been able to use that without Grasshopper like big training?
Yeah. Well, training was from me and my colleagues, but we were able to teach them. Okay, that's how it works, and I think it's very intuitive because I will show it later. Presentation. So, problem was that the Grasshopper script was quite complex. There was a lot of reinforcement groups and reinforcement, and each reinforcement was needed its attributes and input, and if we needed to change something, it was quite tedious work to find the correct parameters. But we did like the workflow, and we decided, okay, let's stick to this workflow, but let's simplify it. So that's how the workflow looks like in the simplest and, let's say, the highest form of the automation. We divided the workflow into 4 parts. First part is geometry. It's a place where you define shape and a rail for each reinforcement or reinforcement group, and you add a name for that reinforcement group. To produce reinforcement Tekla correctly, you need to add attributes, and we feel that, okay, we need to have attributes in one place. So let's go to Excel and create all the attributes, or wrote all the attributes into Excel. Then the keystone is our own component, which simply reads the geometry input and also is linked to Excel, and it creates all necessary data which Tekla components needs to create reinforcement properly.
Just one question about the Excel and attributes. What kind of attributes you are feeling about the shape, size, all the user-defined attributes? What kind of attributes you are feeling?
Well, the shape is defined by the geometry, like polylines, polycurves, but every other attributes which are, let's say, default in Tekla for reinforcement, spacing, rebar, diameter, cover, class, grade, even if it's hook or other things, not the UDAs.
So even the person who don't know Grasshopper, the person can just go to Excel and just modify and create that.
Yeah. How it works in detail: the component is coded with C#, which is my love, but I think it's you are able to produce same component with Python or with some library which reads Excel in Grasshopper.
So we can produce the same component. So it's taking just the input, right? So we can make it cluster. It can be just a simple cluster in Grasshopper. But here you are using C# to get all the information from Excel, right?
Yeah. Because if you use C#, you have more control over the component, how it behaves, and you can update it regularly.
And maybe it's faster as well.
Yeah. So first, the geometry, it's defined in Grasshopper or in Rhino. It depends on the user, but you need to provide for each, each rebar group a name. And in Excel, you have the attributes, like you can see on the right side of the slide, and you again provide for each row a name, and then in the component, the attributes and geometry are matched together with the name. And what the component does is it simply works as a components in Tekla, Grasshopper Tekla lifelink library, and it alters it produces same result as a cover, hook, and group attributes components. So that's the simplification, and then you have all the necessary data which are needed for Tekla reinforcement component in Grasshopper. So let's see how it works. I prepared 2 videos. They are 2 times faster, so it's quite fast. But I would like to describe the basics, and you will see how easy it's to manipulate the reinforcement in Tekla with this workflow. So let's start. First, we have 2 abutments. They are not the same but similar, and we have first one already prepared and reinforced, and you will see how it's easy to copy the reinforcement from the first one to the second one using the similarity between it. What is, I think, also beneficial in this workflow, that how the geometry is defined is up to the user. Generally, there are 3 ways. First, the basic one, if you are you don't know Python or Grasshopper as much, you can simply draw the rails and shapes of your reinforcement in the Rhino on your structure, and then import it into a Grasshopper. Or if you are familiar with Python, you can derive it from the concrete shape, as you can see on the video. Or if you, for example, are into developing some plugins, you can incorporate the geometry creation together with the reinforcement. You will see that in the second video. So now we have the first abutment reinforced, and let's go to reinforce the second one. We will use all the information we produced, and we simply use the similarity between the first one and the second one. So we copy all the workflow once more, and we just alter the input. Of course, it's not say the magic workflow. Sometimes you have problems. For example, if you copy your data from one to another part of the structure, sometimes Rhino reindex the vertices on your brep, so you need to go across your script and do some update, or Tekla flips the direction of cover side for your
this is the common error. This is the common error with the cover, that we have to have minus or plus. It depends.
Yeah, but we know it, and you have to live with it, and it's not so hard to fix it. You will see it a little bit later. Always, you need to do the check. If you just copy the reinforcement from the one part to another, always do the check and see if everything is okay. But right now you see that we reinforced the second abutment in a matter of minute. Here you can see how the Python script defining the geometry of reinforcement looks like, and we have both abutments reinforced. So that's how the script can be used, and you can see that it's not much complicated. Mostly you have
And it's not the spaghetti monster, because you have all
yeah
the data here in this huge Excel
yeah.
spreadsheet. I see that you also have divided that. Do you have any system for division of the Excel?
Yeah, well, mostly I divided the Excel as for the parts. For example, abutment is divided into wing walls, left and right, then the foundation and the main wall. But it depends. It depends on the designer. Also, the naming convention is very important. I developed my personal naming where you can from the name you can decode if it's a straight rebar, U shape, L shape, or let's say vertical, horizontal one. But it's up to user. Regarding the naming, it's very important because name is one of the attribute, and if you want to change something in Tekla, because as you can see, for example, here is the problem with cover direction. So you simply click on the reinforcement group and you will see the name of the reinforcement, and after that you can change the properties and attributes in the Excel.
What will happen? What will happen if someone do it manually just to change this cover in Tekla?
You will rewrite the attribute in Tekla. It will work, but if you recalculate the Grasshopper, then you will again rewrite the attribute to the Excel one. So
yeah, so the Excel is a master. It's a master file. It should be following by the Excel.
Yeah. So for example, if you reinforce this structure and send the Tekla file to another, and the second person doesn't have Excel or the workflow, he can work with it. But if you recalculate the Grasshopper script later, you will rewrite it again. But it's absolutely fine, because sometimes it's a little bit of work to find the proper position of your reinforcement, so you can try it in Tekla, see the result, and if you are okay with that, you just update the Excel. That's again one thing why I like this workflow, because it's quite open, and there are different approaches what you can do, or how you can do it. So this the first video, and the second one is, let's say, the highest form of automation, where we use our library, and you will see how the bridge peer can be reinforced or created and reinforced parametrically within, let's say, 15 minutes. So let's start. We use, as I said, our own library, and the benefit here is that if we create the geometry of, for example, a pier foundation, we don't just create the concrete geometry, but we also stick the reinforcement rail and shapes together, because I believe that if you are a bridge designer and you have, let's say, 5-10 similar pier foundation or piers, you should always go with the same reinforcement scheme. Not like the reinforcement itself, but the shape of the reinforcement should be the same, because it's one office, and you know how to calculate all the things inside.
So what you are showing right now, they are C# scripts that you are using for standard columns, some standard foundations, right?
Yeah. So we created a pier foundation, then we add some ground preparation beneath it. We add columns. We can play with the geometry. Here we can add more piers or remove them. And if we are okay with that geometry, then we can start to do an export. Well, what is maybe a little bit unclear here is where are the reinforcement right now. They are not shown in the Grasshopper, but we create our own C# class, which bears the geometry together with the reinforcement geometry, and we, let's say, unwrap that class at some point. To do so, you need to know a little bit of coding, but again, I think you can overcome with this with the default workflows in a Grasshopper. it will probably create a little bit more bigger monster spaghetti, but still it's okay, it's workable. Here we export the concrete parts into the Tekla. We add some color attributes, and then let's start to creating and exporting reinforcement. First, we unwrap our classes for a different part of the pier and add them to our component. It's, as you can see.
So it's the same component that you presented before.
Yeah. This is the keystone, and you only alter the way how the input is created. We have Excel. It's already prepared, so we link our component to the Excel. We define in which sheet is what bridge or pier part, and then we produce all the data. Here you can see what our component produce. Here we have shapes, rails, and attributes, and we are almost done. And here we simply export everything to the Tekla, and we see the result. It's fine. The attributes are taken from another project, so we need to update them a little bit because not two projects are same. For example, the pier was a different size, but it's okay. Here again, the problem is the cover. We have already described, but it's quite easy to fix.
I like really that you are presenting that not everything lands properly, because I think it's true, and this is how we are working, because we are just reusing the script, and sometimes they can be defined in the different direction, different shapes. So sometimes they need to be adjusted. So also to be showing to all the Tekla user that it's not just magic that everything will see, but you have to make some changes. But as you can see, it's really quick to adjust them.
Yeah. For example, here the shear reinforcement, it wasn't defined by the spacing, but by the exact spacing. So we have a fixed number of reinforcement, and we need to change that value. So we remove some of the reinforcement, and we will see the result. Again, always you need to check the result if it's okay, but it's very, very easy to change something. And what I think is, again, very important, that if you work on more and more projects, you simply creating such a library of your reinforced structures, and you can copy the reinforcement from one project to another project. So if you have different shape of the column on your pier, you once define all the geometry, and then you reuse it or use the Excel. So here we have a result. It's fully reinforced pier from the pier, and then we can, for example, add another pier or remove it. And regarding the drawings, you mentioned the drawings. Well, I think that's very interesting that if you create drawings from this reinforced structure, and then you manipulate the dimensions, not remove part of the structure, but manipulating the dimensions. For example, change the height or the width of the pier foundation. We tested it, and the drawing will kept, I think, maybe 80-90% okay and updated. Mostly you need to change the dimensions because they, for example, go out of the view or so. But even the drawings can be automated, not with the workflow, but based on this workflow. So
I really like if you can just a little bit show the video, and I will have some questions to you, so you can just let me see. I will just put it right there, because we have some questions from David. What is the Afray tab in the Grasshopper? So we are seeing right now. So you made everything. You made everything in C#?
Yeah. No. That's our template, and sometimes we show the videos. Me and my colleague show the videos on LinkedIn, so we like if the logo of our company is present, and we create this template. Honestly, I don't remember how it was done. I think it's somehow that you draw the logo in Rhino, and then you can export the geometry to Grasshopper. I'm not 100% sure right now.
Yeah, but they are, it's something that you made it from company, and users can really, they are for sure trained and know how to use that. And from Willy question, how much time to create this application in Grasshopper? Do you have some measures? How much time you have used that?
Well, how much time it takes me to create this component?
Yeah.
Well, it's hard to say because first you need to learn how to code. That's a never-ending story. And then it's, I don't know, maybe right now 2 or 3 days.
Yeah. So afterwards, you have to also train people to use that one. Okay, so let's go to the next topic about the reinforcement. I think we were going to answer more questions from afterwards, but I see from Alexander that's impressive work and about that lots of bars. So let's go to the next one. I think that many people are not aware of that you can model lots of, for example, terrain. So this is really one of my first scripts in Grasshopper that I will show, that we have the parametric foundation, so we can change a little bit the height of the columns and the width, and we can also play a little bit with our excavation. So we can see the volume, and we can say how much width should be from the foundation as a workplace, what is the slope of that one, and we can also model this 3D geometry that is also really often missing in our part. So this is possible here to import meshes, but Andre has been working a lot about how we can import lots of different data. So we can say a few words, but you are also not just bridge designer, but you're also plugin developer, right?
Yeah, I developed this plugin. It's called Endpoints, and it deals with the import of XML files, land XML scheme. I'm not sure if every designer is this scheme is well known for this designer, but we built our workflows on that, and you can import terrain, not just the terrain like the surface, but also, for example, the terrain of the road or everything which is triangulated in LAN XML, and also alignment. You can build your parametric model on that import, and if you work with the IFC, you can also export directly to IFC from Grasshopper. You can add attributes, create assemblies, and well, originally it was built to fulfill the requirements here in Czech Republic, and at some project stages where we don't need to use Tekla, it's better to stick just with the Grasshopper.
Yeah. So you can export that IFC file, right? So you can try that one. So these endpoints are available. Where are they available? On the Food for Rhino?
Yeah, they are available on Package Manager and on Food for Rhino, but they are somehow licensed. So if you would like to try them, it would be nice, and you can ask for a trial on this email.
Yeah, and I think that is really important, like first IFC, but I think, in my opinion, what is really important for all bridge engineers, it's a land XML file. For those who are not familiar with the land XML file, my workflow, just working with the bridge designer together with the road designer, it was always like we got the land XML file, and I have to go to Civil 3D from AutoCAD and change this to, let's say, 3D DVG, and then import that to Tekla or import that to Grasshopper and Rhino. And it was really lots of work, lots of hassles, especially that if we change that. So what about like if you are importing Land XML alignment? So in what format they will be imported into Rhino?
Well, in XML and even in the IFC, the alignment is written mathematically, and it's written as a vertical profile and also horizontal profile. And one endpoints creates all these profiles as curves in Rhino, and then it also creates a 3D curve, which is let's say the vertical profile flown on the horizontal profile. So you get a NURBS curve, which is very precise, and it respects what road or rail designer designed. No polylines.
Yeah, and I think this part was especially missing for our bridge designers who would like to work with Rhino, that you have to import some of the road line that is polylines, so it's like a straight lines. Of course, we have that Tekla doesn't work on polynomials and curves, but still, if we make a simplification once and then second, and maybe in the design, so we can make an errors if we are just working with the perfect alignment. So we can import that into Rhino and then into Excel. We have from Yordi. Awesome. So this means when a crew from outside has measured the terrain, I can import it to Tekla. So I won't have to draw a river anymore. So if you get, for example, Land XML file, so you can change that, let's say, into mesh. What is the best workflow to import that, Andre, into Tekla?
Well, maybe I can show a video.
Yeah, sure.
It's okay. Yeah. So this is the workflow, and you simply get the XML file. Most of the softwares like Civil 3D or Tekla Civils or Bentley systems, they are able to produce one XML file, and terrain here is written as a let's say mesh. So you simply import that. You can define if it's a BREP or a mesh, or you can, for example, say, okay, I need just the terrain in that area, and set the boundary to your terrain, and you will have this.
I like this one. I like this one because we often get the whole terrain that is a lot of weight and just lots of meshes and polylines. So I like this function.
Yeah. So if your colleague measured the terrain on the site and someone created an XML file from it, you can simply import it to Grasshopper. It's not much about Tekla. You get it to Grasshopper, and how you export it to Tekla, it's up to you.
But you can if it's a mesh, so you can easily export it as a surface, for example. Of course, it will take more memory, but you can But the advantage that it's a Grasshopper mesh, so you can also simplify that. If it's, for example, the measurements from your team was really exact, so maybe you can simplify that, so it will not take maybe decrease the number of meshes.
Yeah.
Whoa, I'm interested by the topography workflow between Land XMLs and Rhinosaurs.
Well, so, I think XML is a mathematical version, so each point has its coordinates, so you get one-to-one copy of the software, a copy of the terrain from the original one. That's the point here.
Yeah. Carlos, what is the cost of the plugin? Can you tell it, or maybe you people have to try it first trial and just write a message? I don't know.
Well, they can buy it first, but you can. I will send the link to the chat, and you can read the guide to the plugin. I think it's the best.
Perfect. Thank you, Andre. If you have time, please stay with us to the Q&A session. We have some questions still that I haven't answered. So after the session, if you will have time to join, so you will be in the background.
Okay, thank you.
Thank you for sharing this example. Like, we have some comments that was so sexy, the workflow that you showed with reinforcement, and I can tell that this is sexy, and it's a different workflow that we are used to work. And it's not just about the reinforcement, but we will talk about that later. Thank you very much, Andre. Okay, so let's go to the next topic. So we have 3 last topics. I will be quick here. We are going to talk a little bit about the pre-stressing cables. So this is something that we are designing a lot in bridges. Here is the workflow with Sophistic. Then we have exported the geometry tandem file. It was easy, simple file with the S with its station. So we can see every single half of the meter. And then we have U and V. So we have the vertical and horizontal dimension. So this was a representation of every single cable. So that file can be, even if you don't have this live link between Sophistic and the Grasshopper, but I will tell you more, that is the link. You can also use this kind of text files. So this text file can be read by the Grasshopper, and we can put all the reinforcement, pre-stress reinforcement in that. In our bridge. So here is the example. This is a bridge, one of the most complicated pre-stressing system, that the small bridge that I have ever worked. It's only 4 cables, and I cannot imagine to model everything and to make drawings for all these cables manually. So you can see that it's a 16 cables in every single beam, and it's a slope on the whole deck. So every single cable is different. So we have modeled everything. We exported file from Sophistic, and then we have imported that into Tekla. So we had all the geometry. We could parametrize the same with the pre-stressing tendons. So we could change a little bit our attributes and what is the side and what is the length. So this kind of pre-stressing cables, the workflow Grasshopper, it's really amazing for bridges. The same for not only pre-stressing cables, but all geometry that goes through the bridge. Let's say that we have electrical cables or water pipe system, that sometimes we have to play a little bit with some parameters to not place our cables between, let's say, some reinforcement, some really important columns. So we can play a little bit with our component. So it's not just for concrete or just cables, but also for all additional stuff that we model can be also parametrized. And the next one, it's not our work as bridge designers. It's not just only bridges. Sometimes we have to work also with tunnels and retaining walls. So I will show you just a few examples that sometimes you can also use Grasshopper for that. So I will show you the simplest way, simplest example, how we can use Grasshopper. So in this case, we have the standard profile of our tunnel and the table form. So this table could be parametrized, so we can create our model. So in this case, we can see that all these parameters are creating the shape of this tunnel. So we can change the thickness, so the width of the tunnel and the size, and then we can produce our 3D model in Tekla. So these elements we can a little bit adjust. And for modeling tunnels on tunnels or portals, this is amazing workflow that you don't have this standard shape in Tekla, but you can achieve that with the use of Grasshopper. Here on the right side, we have Rhino. On the left, we have Tekla. And we can see that with the white point, we are changing the position. For everyone, bridge designer or tunnel designer who've been working in the infrastructure project, we know that the road line is changing every single week. So on Friday, we usually get an update of the road line. So we can see that here we get all the updates. Every time when we are changing road curvature, this portal will be aligned. And the same is with the reinforcement. So we took the next step, and on our portal at the end, we could also make the reinforcement and everything parametric. So the same as Andre showed it, we can also make it for non-standard reinforcement. So in this example, we have the longitudinal bars that will be really extremely difficult to make it manually. The same end reinforcement, just distributed on the curvatures, and the same with the arc reinforcement. Even if you try to do it manually, it will be super, super difficult. So Grasshopper is also amazing, not just for repetitive tasks, but also for difficult tasks. And this example, it's also showing the retaining wall. So sometimes we have some retaining wall before bridge and after the bridge. Here, a really cool workflow about how you can model that one with the different position of foundation level. You can choose from the program what is the height of every single wall, what is the foundation size, and then send it to Tekla or even to different software like Quadri for those who are working in the infrastructure, so you can send it directly there. So it's not only for bridges, but it's also for associated structures as well. And the last point that I would like to present today is a finite connection with finite element software. And compared to Bridge Creator, which is good for modeling of 3D geometry, I think this is the biggest benefit of using Grasshopper. So Grasshopper can be connected with lots of different software. So we have Caramba, we have Oasis, we have 3D Midas, we have CI Engineering, Sophistic. Let me know, just write a comment. Maybe you are already using some of the software for calculating bridges. So we can use FEM Design, Robot, Idea Statica if we are working with the steel connection. Just let me know if you are using some of them for calculating bridges. We have the workshop about using Sophistic. I have the developer from Sophistic. This is they put a lot of effort to make this connection, and I see that this also is changing in our industry, and we have more and more software developers, software providers that also have this plugin between Grasshopper and, let's say, finite element software. So this one, of course, if we have this connection with the finite element software, so we can also send this information into Tekla. Grasshopper with the CADWorks, yes, CADWorks, they have also own component for plugin for that. So here there are some examples from the Sophistic that you can make a composite bridges, or you can make a segmental free cantilever bridges. They also develop their own tools. So most of the work you don't even have to design from scratch in Grasshopper. You can just use the components that they've been creating. Like in this case, you can define all the parabol here on their components. So this is one of the components with the really cool graphics that is available in the Sophistic. We have some comments that, for example, Mario is using Dubal RFM to analysis. They have also the link, this one, and we can also work on beam structure and the mesh structure. So here, some of the, let's say, I will show the workflow, how to just show how we can define every single profile in Grasshopper with the cantilever beams, with the top floor and bottom floor, and just send it to Sophistic. So here we have the workflow with the pre-stressing cables. We can see that we are just doing the curvature, so we can see how this bridge was adjusted. So we can do everything inside Grasshopper and then send this model to Sophistic. And then maybe if it is too simplified, we can make a separate one for the beam models. So here we are sending a new file. So we will see after the calculation, so all the deck will be inside Sophistic. The same with the another software that we have, Middles Civil. And I just use the video from YouTube, from the Panda, that you can also define all the geometry, like all the B-wraps, all the columns, even the mesh that we have defined for the pavement. And then send this to another software. So here we are generating the file, the text file that can be imported. So it's just a semi-live connection. We can just import all the geometry, so we don't have to use the tools to create geometry. For example, in Midas, we can just connect that. So for those who are interested, I'm going to invite Midas Civil 3D to make a workshop and show more this workflow with bridges. And with FEM Design, they are also published lately. They have connection with Grasshopper and FEM Design, so we can also make a lot of different types of bridges, define loads, define combination, and do it in Grasshopper into automated way. And everything what is inside Grasshopper can be sent to Tekla. Okay, so that was all examples that I prepared for you, and as it was before, which would like to is most interested for you, which would like to script you would like to achieve. Like different people have different wishes, and maybe some of you were interested in the terrain, so we can maybe share some cool examples with that. Maybe some particular finite element software was, or maybe 2D drawings were interested. Just write in the comments which area you are most interested in. So I will be also curious what is the important point for you. Okay, so we have some first answers. So Mario, reinforcement. So this sexy workflow from Andre. We have Matej with the finite element software. That's good that you see the benefits of connecting Grasshopper with finite element software. Again, we have Yuka. So we have 2 for 1. So Sylvester, we have, let's see, lots of answers. Which Grasshopper? No, I just asked about one, not all of them. Second, the 2D drawings. Again, Ernesto, reinforcement. Arturas, 3. Okay, so everything's go. I have lots of examples for reinforcement. So I see anti 3 as well. So you can see, but also lots of you are interested in the finite element software. So that's also a good sign. This also shows me the direction, what kind of next workshop I will organize. So what about if I will tell you that you can, what if you would like to get the place to get all these Grasshopper scripts and even much more? Will you be interested? I'm working on creating the community that will gather. So what I see that lots of people are voted for many of the scripts. So maybe you will be interested to get a place that you can learn from the best in the industry and get all the script that you can reuse that. Because sometimes working just for reinventing the wheel, you're just missing your proper time and you can just reuse that work. So just tell me, just write in the comments if you will be interested in the place that you can download all today's scripts that I presented.